talking about a very important parameter today. So we are going to discuss BOD, that is biological oxygen demand, in a bit detail today. So this is the chart which I got from the website of CPCB, that is Central Pollution Control Board. So it mentions primary water quality criteria for bathing water. So you can see biological oxygen demand of 3-day 27 degrees Celsius should be 3 milligram per liter or less. Let us discuss what exactly these things mean. First of all, what is BOD, which I have explained in my last lecture. But again, once again, to tell you, it is basically the oxygen required for a set of organisms or seeded organisms to consume the organic matter in the given effluent sample. So BOD is nothing but the oxygen consumed by these organisms. So 3 day means in a time period of 3 days, and when it is incubated at 27 degrees Celsius. So let us try to understand more about this. So as I said, BOD is nothing but biological oxygen demand, which is nothing but oxygen consumed. By whom? By organisms in the given sample. So these organisms are basically eating away the biodegradable matter, and while doing that they consume oxygen. So uh, so the amount of biodegradable matter present in the effluent is nothing but proportional to the oxygen consumed by them. Oxygen consumed, biomatter. Now what is the procedure for that? So standard procedure is followed. So in a 300 ml of beaker, the water sample is taken and it is kept at 27 degrees Celsius for 3 days. On day 0, dissolved oxygen is measured, say the value is X, and on day 3, again the dissolved oxygen is measured, say the value is Y. So definitely the dissolved oxygen which was present on day 0 is more, that is X will be always greater than Y, and since it is consumed by organisms it will reduce. So the difference between X and Y is nothing but our BOD. Now a valid question will definitely come in your mind, that why it is so that even in the document it is mentioned 3 days, and why not 7 days or 10 days. So for that we need to understand a simple graph. Let me move ahead. So if I plot this graph, this is y axis and this is my x axis, which is time, and my y axis is the oxygen demand. So basically how much oxygen is consumed is measured. So initially the organisms are in lag phase. Then when the activity speeds up after a day or so, the organisms will use more and more oxygen. So the oxygen demand increases. And after 5 days, till 5 days, the carbon consuming organisms are prevalent in the sample. And after 5 days, the nitrogen consuming organisms will also start competing. So this actually gives us a false BOD if we measure it after 5 days. So till 5 days, the the carbonaceous bacteria are prevalent, but after 5 days, we have nitrogenous bacteria also prevalent along with carbonaceous bacteria. So this is nothing but CBOD, that is carbonaceous biological oxygen demand, which we are interested in, because primarily when we talk about biodegradable matter we are talking about carbon. And after 5 days, the nitrogen consuming bacteria, they also have a significant activity, and because of which our reading will also record NBOD, that is nitrogen consuming bacteria, but we are interested in CBOD, and that's the reason why generally BOD is measured for 5 days. Generally it is BOD 5, and to be on safer side they do BOD for 3 days. So this is the concept. So what happens when the nitrogenous bacteria, when they pick up their activity, so they are also consuming the oxygen, and along with the carbonaceous bacteria, so they add to the BOD value. So you will get BOD values higher after 5 days, but which will not be a true representation of the organic matter. So as per the definition, as we mentioned earlier, that BOD is nothing but the oxygen required for organisms to degrade biodegradable matter, which is nothing but a carbon containing matter. So that's a small concept. Now let us dwell into how exactly the BOD is measured. So as I said, BOD is nothing but the difference between the dissolved oxygen. So DO at day 0 minus DO at dissolved oxygen at day 3. This is the difference. But the problem comes when these readings are far above the capacity of the DO meter. So for example, if DO meter is having a highest reading of 10 milligram per liter, and we are measuring a very dirty water, for example a nala water or a sewage water which is having a very high BOD, say like 250 milligram per liter. So in that case what has to be done? And also there is another problem. Generally the difference between DO0 and DO3 at after 3 days should be more than 2, the reason is when it is less than or equal to 2, the system error or the instrument error is generally taken into account. So if the difference is more than 2, then system error is less, and if it is less than or equal to 2, there may be a system error or the instrumentation error, so it might be a false reading. So generally it is required that our DO0 should be around 7 minus 4 is equal to 3, which is 3 milligram per liter. But if it is say 7 minus 6 equal to 1, so 1 milligram per liter reading falls into the uncertainty zone. So this may be a calculation mistake, or this may be a instrumentation error of the intrinsic instrumentation error. So the required difference which should be more than 2. But now another question is, what if the BOD of the sample is like 250, 300, then what to do? So what they do in a laboratory is they will dilute the mixture. Now for example, so there is a direct formula also, but I don't want to give that, because let me give you a basic concept and it will be easy for you to remember after that. So for example, we have a very bad water, say here. So this is my sewage water, say I will call it as a sample water, and the volume is Vs. So I will be diluting this sample because I want to reduce the dissolved oxygen to such a level that my DO meter should be able to read that. So what I will do, I will take a distilled water or a water which is having a very less BOD. So this is kind of a clean water I am taking. So this is a dilution water, I will call it D, and a small quantity, say this quantity of water I will dissolve in my dilution water. So this is a small quantity of sewage water which I am picking from my Vs, and making a mixture, so that the DO in this mixture is reduced to a greater extent, which then becomes easy for me to measure it using the DO meter. Now we have to take the balance that is oxygen balance on this. So I will be multiplying Vm with the concentration of oxygen. So here I am calling concentration of oxygen as BOD M. So BOD M is a concentration. It is nothing but in terms of milligram per liter into Vm, which should be equal to BODS into Vs plus BODD into Vd. So here I am just taking a mass balance. I am not doing anything other than that. And what I am interested in is finding BOD-Vs. So now it becomes simple. I am writing it here now, the equation. So BOD-Vs, which is what we want to find, will be equal to BOD M Vm minus BOD D into Vd upon Vs. Now this is my working formula, which I can use when I am trying to find out the BOD of a very bad water quality. Now again, if my dilution water is a distilled water, so my BOD is approximately equal to 0. So this means there is no organic matter present in that. So my this quantity can go down to 0 and I can get a very simple formula for this. BODS is equal to nothing but BOD VM upon Vs. So Vm is nothing but the volume of mixture, that is the total volume of mixture. Vs is the volume of sample which I added, so that is measurable. And BODM, as I said, that this is a BOD of the mixture which is which can be easily calculated using the meter. So all these three quantities are known to me now, and hence I am able to calculate this particular quantity, that is BODS. Yeah. So thank you friends. I hope you learned something out of this lecture. We dwelled into basic concepts of BOD and also derived a simple formula. If you like this video, if you found this informative, please kindly like, share and subscribe, and also comment with your suggestion what you would like me to make video on. Is there any important aspect you want to understand? Till then, thank you and let's meet again.